In this video, we'll go over the basic principles of solving a second-order linear constant coefficient ODE. So what we mean by that is a differential equation of this form, say ay double prime plus by prime plus cy equals f of t, where a, b, and c are constants. They're just numbers. So these types of equations come up in mechanical systems and electrical systems. So they're going to be a major thing that we'll study this term. So the first thing we want to note here is that our independent variable is t, our dependent variable is y. So let's start with this. Let's call this equation equation star. And let's suppose that we have a y that's a solution to that. So let's say y sub p, and the little p is going to stand for particular. Yp is a solution to star. And then we're going to have another function we'll call y sub h. And let's say that y sub h, and h is going to stand for homogeneous, is a solution to, so I only wanted one star here, so it's going to be a solution to this equation, ay double prime plus by prime plus cy, so it's looking just like that, but it's going to be homogeneous, so the right hand side will be 0 rather than f of t. All right, so we'll call this equation double star. So what we want to do is consider a new function y, which is the sum of those two. So it's y sub h plus y sub p. And if we have such a function, then its first derivative is simply the sum of the derivatives of these two. So that's y sub h prime plus y sub p prime. And then, whoops, the same, I'm getting a little ahead of myself, the same holds for the second derivative. So y double prime equals y sub h double prime plus y sub p double prime. So what I want to do is let's take y and put it into our original equation star and see what happens when we do. So remember, we know y sub p is a solution to star, y sub h is a solution to double star, and what I want to do is check and see if y itself, which is the sum of those two, is a solution to star, our original differential equation. So the left-hand side, when I put everything in, left-hand side equals, we'll have a times y sub h double prime plus y sub p double prime, because remember, I'm substituting this y, which is the sum of those two, in for y. This is plus b y sub h prime plus y sub p prime plus c times y sub h plus y sub p. Okay, and then when we do that, what we can do is distribute a, b, and c into these guys and rearrange the terms so that we have all the y sub h terms together and all the y sub p terms together. So we get a y sub h double prime plus b y sub h prime plus c y sub h. Okay, so that takes care of a y sub h double prime, b y sub h prime, and c y sub h. Now we need the y sub p parts, so we have a y sub p double prime plus b y sub p prime plus c y sub p. Now if we look at this first part here, this is the left side of double star, and remember, y sub h is a solution to that, so that means that this part must turn to 0. This is equal to 0. And then over here, this is the left-hand side of both of our equations, but since y sub p is a solution to star, that means when we put y sub p in these three places, this statement's true. So that means ay sub p plus by sub p plus, or ay sub p double prime plus by sub p prime plus cy sub p equals f of t. So we can replace all of this with f of t. And of course 0 plus f of t equals f of t. So what was the point of all this? Well, what it shows us is that if we have a solution to our second order ODE that we're trying to solve, and we have another thing that's a solution to the homogeneous equation created by just turning this f of t to 0, if we add both of those together, then we also have another solution to our original equation. So our strategy for solving this kind of thing, like star, is going to be that we're going to try to find our homogeneous solution, y sub h, and then we'll find a particular solution, y sub p, and then our general solution is going to be the y sub h and y sub p added. So what we need to do next is two things. First of all, figure out how to find homogeneous solutions to equations like this. Then we'll find out how to find particular solutions to equations like this. And then we'll solve general equations like this by adding homogeneous and particular solutions. So in the next video that I'll make, I'll go over finding the homogeneous solutions to equations like this one, double star.